Assalamu alaikum guys, I am Hafsa Arif and here is my fourth lecture about DSP. So we are going to study about discrete Fourier transform today. I'll explain this circle later. First of all, we know that we have DT signals, discrete time signals, and it has two types, periodic and non-periodic and periodic. On periodic signals we apply Fourier series, and on non-periodic signals we apply Fourier transform. Then today we are going to study about Fourier transform. So here's the formula for Fourier transform, and we will also learn how to apply inverse Fourier transform. So here's the formula for inverse Fourier transform. So now we have a signal x of n having 1, 0 and 3. This is x of 0, x of 1 and x of 2 in time domain. Here we can see that we have 3 samples, so n is equal to 3. Now we want to find x of 0, x of 1 and x of 2 in after applying Fourier transform. So for x of 0 we have this formula. We are going to apply this formula. Here we can see that x of 0 is equal to summation 0 to 2 x of n will be here, and here we have because of the value of k is equal to 0 in this formula, this will become 0. So x of 0 would be x of 0 multiplied by e of 0 plus x of 1 multiplied by e of 0 plus x of 2 multiplied by e of 0, and this will become 1 plus 0 plus 3, and that is 4. So x of 0 is equal to 4. So now we are trying to implement Fourier transform in it. We have a x of n that is 1, 0, 2 and 4. We have 4 samples, so n is equal to 4, and then we are trying to apply f of t on it, and the formula for f of t is this, and we are trying to find x of 0, x of 1, x of 2, x of 3. Okay, so now if we find x of 0, we have summation 0 to 3 x of n, this is n, and then e of minus 2 pi j n. In place of k we have 3, we have 0 divided by 4. So x of 0 will become x of 0 e of 0 plus x of 1 e of 0 plus x of 2 e of 0 plus x of 3 e of 0. So we have, this is capital X. X is equal to 1 plus 0 plus 2 plus 4, that is 6, 7. Now the next thing is x of 1, and that is summation from 0 to 3 x of n e of minus 2 pi j n. In place of k now we have 1 divided by, in place of n we have 4. So this will become x of capital x of 0 e of 0 plus x of 1 e of minus 2 pi j. In place of n now we have 1 divided by 4 plus x of 2 into e of minus 2 pi j. In place of n now we have 2 divided by 4 plus x of 3 e of minus 2 pi j. In place of n we have 3 divided by 4. So now we are having these type of things. Now we want to find the values of this and this. we have a formula E of j theta is equal to cos of theta plus j sine theta, but this is a lengthy process. We have to find cos and sine and then add those values every time, and that is a lengthy process. So for this thing we are going to use this circular approach. So I'm going to tell you how we are going to use it. We have different positions on the circle and we have different values for those positions. So these are the most common position, and these are their respective values. Now what we want to find, we have E of minus 2 pi j divided by 4, that is E of minus pi j divided by 2. So how we are going to find it? Let's see. We need to find E of minus pi j divided by 2, and from this we see that theta is equal to minus pi divided by 2. So where is minus pi divided by 2 on this circle? If we see that if we move from this position in the clockwise position, minus pi by 2 will be here, but instead of watching it in the negative side, we can do a thing that we can add 2 pi to it and see where this lies. So where this lies, we have minus pi plus 4 pi divided by 2, and that is 3 pi divided by 2. So on this circle we have 3 pi by 2 here, so its value is minus j. That means we can use the value of E of minus pi j divided by 2 is equal to minus j. Now the next thing we want to find is minus 4 pi j divided by 4, that is minus pi j. That means we want to find E of minus j pi, and from here we have theta is equal to minus pi plus 2 pi is equal to pi. So the value of pi is minus 1, so we can use E of minus j pi is equal to minus 1. The third thing is we need to find E of minus 6 pi j divided by 4. That means E of minus 6 pi j divided by 4, that is equal to E of minus 3 pi j divided by 2. Theta is equal to minus 3 pi divided by 2 plus 2 pi, it is minus 3 pi plus 4 pi divided by 2, and that is pi divided by 2. So from here we can see that pi by 2 is this position, pi by 2 is this position, so we can use the corresponding value, that is j. So E of minus 3 pi by 2 is equal to plus j. So now we can see that we have found those values. Once it looks difficult, but once you are used to it, you will find it really easy. So now we will put those values in this equation. So we have x of 0 is equal to 1, x of 1 is equal to 0, x of 2 is equal to 2, and x of 3 is equal to 4. We are going to put those values in here. X of 0, we have x of 1 is equal to, x of 0 was 1 multiplied by 1 plus 0 multiplied by this value, that is minus j, plus 2 multiplied by this value plus 4 multiplied by this value, and that is x of 1 is equal to 1 minus 2 plus 4j, that is minus 1 plus 4j. Now we are going to find x of 2, and that is equal to summation of 0 from 0 to 3, and then x of n e of minus 2 pi j, and k here is 2 divided by 4, and that is equal to x of 2 is equal to x of 0 e of 0 plus x of 1 e of minus pi j n is 1 plus x of 2 e of minus 2 pi j plus x of 3 e of minus 3 pi j. So now we have e of minus pi j. From this we can see that e of minus pi j, here we have minus pi plus 2 pi, that is equal to pi. So pi, the value of pi is minus 1, so we're going to use 1, x of 0 is 1, e of 0 is also 1, plus x of 1 is equal to 0 multiplied by this value is minus 1, plus x of 2 is equal to, x of 2 is equal to 2 into e of minus 2 pi j. We have minus 2 pi plus 2 pi, and that is equal to 0. So from this circle we have value of 1 at position 0, so this will be 1 plus 4 into e of minus 3 pi j minus 3 pi plus 2 pi, that is equal to minus pi. We can add again, that is equal to pi. So at pi we have value of minus 1, so we can use minus 1 here. Now we have 1 plus 2 minus 4, that is minus 1, so x of 2 is equal to minus 1. Now we can find x of 3 like this. I'll show you. 0 to 3, x of n e of minus 2 pi j n, we have k3 here divided by 4. X of 3 would be x of 0 e of 0 plus x of 1 e of minus 6 pi j divided by 4 plus x of 2 e of minus 12 pi j divided by 4 plus x of 3 e of minus 18 pi j divided by 4. Now we know that x of 3, that is 1 into 1 plus 0 into whatever plus 2 into, now we need to find minus 12 pi j divided by 4, that is minus 12, that means minus 6 divided by, no, minus 3 pi j, that is minus 3 pi j, minus 3 pi plus 2 pi plus 2 pi, that is equal to pi, and pi is minus 1 plus 4 into minus 18 pi j divided by 4, that would be minus 9 pi divided by 2, minus 9 pi divided by 2 plus 4 pi is equal to, sorry, we can add 6 pi, this is more negative, so we will have 3 pi divided by 2, so 3 pi by 2 on this circle is this, and that its value is minus j. Now we have x of 3 is equal to 1 minus 2 minus 4j, that is minus 1 minus 4j. So we have x of k is equal to, what was x of 0? Sorry, x of 0 was 7, x of 1 was minus 1 plus 4j, x of 2 is minus 1, and x of 3 is minus 1 minus 4j. So this was all about Fourier transform. We have transformed our time domain sample into the frequency domain samples. Now we will talk about inverse Fourier transform, but before that we want to discuss about something about Nyquist theorem. So Nyquist theorem says that the number of samples should be twice than the f maximum, and if you want to find f maximum, this will be n divided by 2. We had our n is equal to 4, that means we have f maximum is equal to 2. That means from the samples from here we have this x of 0, x of 1, x of 2, x of 3. So this sample has the highest frequency, then this is lower than that, this is lower than that, and this is lower than that. The maximum frequency lies here. So whenever we talk about we are removing lower frequency components, we will remove from this side, and whenever we are saying that we want to remove high frequency components, we will remove this part or maybe this part. So this is the distribution. And the other thing is the value of maximum frequency. Okay, just leave that. So now let's jump toward the inverse Fourier transform. We have this formula for inverse Fourier transform. Okay, now we had the signal x of n is equal to 7 minus 1 plus 4j minus 1 and minus 1 minus 4j. Was this function? Okay, 7 minus 1 plus 4j minus 1 minus 1 minus 4j, and this was 7. Okay, fine. So we have this frequency domain. We have the this is x of k. We have these frequency domain components. Now let's do something. Let's remove a lower frequency component, that is this thing. Let's do it. Let's convert it to 0. Minus 1 plus 4j minus 1 and minus 1 minus 4j, and let's call it x1 of k. Now we are going to apply inverse Fourier transform on this signal, and we are trying to get x of n is equal to 4 samples will be there. So x of 0 is equal to 1 divided by n, that means 1 divided by 4 summation of 0 to 3, then x of k here e of 2 pi j k and n here is 0 divided by 4, so we will have 1 divided by 4 x7, sorry, 0 minus 1 plus 4j minus 1 minus 1 minus 4j. So this has become plus 4j minus 1 minus 1 minus 1 minus 3 divided by 4. Okay, now x of 1 is equal to 1 divided by 4 summation of 0 to 3 x of k e of 2 pi j k, and here is 1 divided by 4, that is something like 1 divided by 4. Here is x of 0 e of 0 plus x of 1 e of 2 pi j divided by 4 plus x of 2 e of 4 pi j divided by 4 plus x of 3 e of 6 pi j divided by 4. So we will have 1 by 4, x of 0 was 0 plus x of 1 was minus 1 minus 4 plus 4j. E of 2 pi divided by j is e of pi divided by 2, and pi divided by 2 here it is j, so we will have j here plus x of 2 was minus 1, e of 4 divided by 4 is pi j, the value of pi is minus 1 here, plus x of 3 is minus 1 minus 4j, and e of 6 pi j divided by 2 is 3 pi divided by 2, 3 pi divided by 2, and 3 pi divided by 2 here is minus j. So we'll have 1 by 4 0 minus j minus 4 plus 1 plus j minus 4. So this will be cut off. Minus 4 is minus 8, minus 8 divided by 4 is minus 2. This is x of 1. Now x of 2 is equal to 1 by 4 summation of 0 to 3 x of k e of 2 pi j k, and here is 2 divided by 4. This will become x of 2 is equal to 1 by 4 x of 0 e of 0 plus x of 1. Okay, so I have calculated x of 2 and its value is 1 by 4. You will do it by yourself, and then I have calculated x of 3 and you will calculate it by yourself too. Its answer is 9 by 4. So now we have got this x of n, and our previous x of n was, let me tell you, it was 1 0 2 4. That it was 1 0 2 and 4. So we can see that if we compare those values, we had removed a lower frequency component, and then we have converted that signal into time domain, and that was the real signal in time domain. So if we compare these values, we can see that the magnitude has reduced. This has magnitude of 1, and this sample has magnitude of minus 3 divided by 4. This has magnitude of 0, and this has the magnitude of minus 2. Here 2 and 1 by 4, here 4 and 9 by 4. So the magnitude is decreased significantly. So what we have reduced, that removing low frequencies will do, first of all, it will decrease magnitude. Second thing is, if we plot both signals, we will see that there will be more fluctuations with, let's say this is our x2 of n and this is our x1 of n. So we will have more fluctuations with x2 of n. Why this thing has happened? Look, we know that the lower frequency components are much slow and smooth. Just like we have a sine signal here, it will start from here and will end here. Frequency of this signal and the frequency of this signal is different. This one has less frequency, this one has more frequency. So we can see that this one is more smooth and this one has more fluctuations. So if we remove a lower frequency component from our signal that is composite, our fluctuations will increase. And if I draw those signals, let's say this is our x1 of n, okay, and our x2 of n would be like, so this is x2 of n, this will be x1 of n. So we can see that if this is x1 of n, this is x2 of n, its lower frequency is removed, and this is the original signal, and this signal is a signal in which the lower frequency is removed. So we can see that it has more spikes and it has more fluctuations. Sorry, I missed one thing. I should have drawn this signal a larger signal because its magnitude is also going to decrease. So if this is our original signal, this will be our lower frequency removed component with lower magnitude but more fluctuations. Now this is your task to remove a high frequency component I have told you that by Nyquist theorem we have seen that this is the highest frequency or the maximum frequency. So now this is your task to remove this sample, make it 0, and then apply inverse Fourier transform on it, and then reduce information that removing high frequency will smooth your signal, because we have seen that high frequency components have more fluctuations. So if more fluctuations are removed your signal will be smooth, and removing high frequency means you are going to apply a low pass filter. Okay, so you will have to reduce this information. And also here, when we remove low frequencies, this is a high pass filter. So guys, that's all for today. Share your results that you have deduced by removing high frequency components, and if you find anything difficult in it, do tell me, I'll explain it to you later.